we had to look at series circuits, and I'm going to give you an overview in this video of what we talked about. It's a number of topics kind of combined together. A series circuit, I've drawn two of them. It's a circuit where the electrons have only one path to follow. So in this case, that's the only path. In this case, this is the only path. So there's only one way for the current to go. As a result, the current is the same everywhere in the circuit. No matter where you look in the circuit, the current is always the same everywhere in that circuit. When it comes to resistors, resistance is additive. In this case, I only have one resistor. It's 100 ohms. Therefore, the resistance for the whole circuit is 100 ohms. But in this one, I have two resistors. R1 is 100 ohms, R2 is 50 ohms. So my total resistance for the circuit is 150 ohms. The voltage here has to push through 150 ohms, not just 100. As a result, the voltage is also proportionally allocated to each resistance. That is to say, the voltage on this resistor and this resistor, because the resistances are different, the voltage to push that current through is also different, proportional to their sizes. We'll go through the math in just a moment. Let's first of all look at this one. I want to find out the current on this circuit. Well, I know the voltage is 30 volts. There's only one resistance, 100 ohms, so my current is going to be voltage divided by resistance. Notice I use V here. V, E, doesn't matter, not in our context. In your electronics courses and your electricity courses, you'll get into perhaps the subtleties between E and V. For our mathematical purposes, we'll use them interchangeably. So, the current is voltage divided by the resistance. So in this case, it's 30 volts divided by 100 ohms, 0.3 amps. Simple enough. Here's where it gets a little more involved. Because I have two resistors, to figure out the current for the whole circuit, I have to consider the total resistance of the whole circuit. My voltage is still 30 volts. My resistance is the 100 plus the 50, that's 150 ohms. So my current is the total voltage divided by the total resistance. So it's 30 volts divided by 150 ohms, so it's 0.2 amps. A little less than this one, but you'd expect that because there's more resistance. The voltage, as I said, also gets allocated proportional to the size of each resistor. So in this case, for me to find the voltage in R1 and the voltage in R2, I have the same current in both, I can use Ohm's law. Because I've got resistance, I've got current, I can figure out how much voltage was allocated to each. So the voltage on resistor 1 is 0.2 amps, because I discovered that's how much current is flowing, times the 100 ohms, which is 20 volts. So there's 20 volts allocated to that resistor. V2, so the voltage going through resistor 2, is 0.2 amps, again, the same current everywhere, times the 50 ohm resistance is 10 volts. Less voltage there to generate the current, more voltage here to generate the same current, because there's higher resistance here and lower resistance there. Hope you find that helpful. Just remember with series circuits, one path, one current, voltage is allocated based on different levels of resistance, and the resistance for the whole circuit is the sum of all resistors.